I would now like to look at some examples of solving trig equations. We're going to start out with some of the simpler equations. This first one asks me to solve 2 cosine of theta minus the square root of 3 equals to 0, first on 0 to 2 pi, and then it asks me to give all solutions. So starting out, I'll copy down my equation, and my first goal is I'd like to get cosine of theta on one side by itself. Use simple algebra to do this. Remember to always add and subtract first. So I want to add over the square root of 3. I'll have left 2 cosine of theta equals the square root of 3. And then always divide last and divide out the 2. Now when you're dividing, you have to be careful where the number you're dividing by is. If the number you're dividing by is a constant or a coefficient on your trig function, it's a perfectly legal thing to do. If the constant that you want to divide out is contained within your angle, in other words, it's a multiple of your angle, you absolutely cannot divide numbers that are next to your angle out. Okay, in this case, I don't have a problem. I have cosine of theta equals the square root of 3 over 2. Now, I've solved for my trig function. What that means is I can now draw a picture of what this would look like. In other words, I don't know what theta is. That's what I'm trying to find. In other words, here at this point, I want to know what is theta. But knowing that the right-hand side of my trig function is the square root of 3 over 2, that means I know an x value and I know an r value. Now, r is always positive, and in this particular example, you can see that x is positive. Which quadrants are x positive in? X is positive in quadrants 1 and quadrants 4. That means I should draw at least 2 triangles when I'm trying to represent this in pictures. In quadrant 1, here's a triangle. In quadrant 4, there's a triangle. Now both of these triangles are going to have the same reference angles. Let's label our x and our r. The x is the square root of 3. That'll be the same for both triangles. The r is 2. That will be the same. And then we need to determine if this is a triangle that we know. Well, we know that if we have a hypotenuse of 2 and we have a side of the square root of 3, then this is one we know. This side in the first quadrant, the other side will be 1. This side here would be negative 1. What's the reference angle? The reference angle is a 30-degree angle. Okay, now, this particular problem wants us to find theta, where theta is in the interval from 0 to 2 pi. In other words, it's a positive value. The other thing we notice is that they're asking for the answer in radians. In other words, if they're asking you for an answer between 0 and 2 pi, the 2 pi being there means that they want the answer in radians. If they ask you to solve from 0 to 360, then you know that that would be asking for a degree measure when you finish. Alright, we already know one of our answers is 30 degrees, and we can convert that to radians here in a little bit, and we'll have that one answer. We have another answer, though. Always measure the other answer from the positive x-axis around to the other terminal side. In other words, this would be the other angle. Okay. First of all, let me write down my first angle. The first angle would be 30 degrees, and like I say, I'll convert that to radians here in a little bit. The second angle, the one I've just drawn, would be 360 degrees minus 30 degrees. And the reason we know that is we know that the reference angle down in here is 30 degrees also. Okay, so that would be 330 degrees. Okay, in radians, those two angles are 30 degrees we know is pi over 6. That's the answer in quadrant 1. And then theta sub 2. Think about it this way. We know that this angle over here is 2 pi. 2 pi written as a multiple of pi over 6 would be the same thing as 12 pi over 6. And so the other angle is 1 pi over 6 away from that, and so this would be 11 pi over 6 as the other answer. There are the two answers. Now, these are the answers over 0 to 2 pi. Okay, what would happen if I need to give all solutions? Well, what happens there, all solutions basically means that for the quadrant, for the answer in the first quadrant, I could have multiple answers. In other words, I'm taking that 30-degree angle and I'm rotating it around multiple times. And when I'm rotating it around, I'm understanding that I'm rotating it around an extra 360 degrees. I can either rotate it forward to get other answers, or I can rotate it backwards. In other words, other answers are angles that are coterminal to 30 degrees. Same thing with the 330 degrees. Other angles are coterminal to 330 degrees, which means I'm rotating them around some multiple of 360 degrees. So to give all solutions, here's what I do. Theta sub 1 would equal pi over 6 plus n times 2 pi for n an integer. Okay, an integer multiple of 2 pi are things like 1 times 2 pi, negative 1 times 2 pi, 2 times 2 pi, and so forth. And so this would be my first solution in my all solutions. And then my second solution would be theta sub 2 equals 11 pi over 6 plus n times 2 pi. If they're asking you to give the answers in degrees, the way that I would write all solutions would be, the first one would be theta sub 1 equals 30 degrees plus n times 360. And the second one would be 330 degrees plus n times 360. You're just converting your angle measures into degrees, and then that would give you all solutions. Let's look at another example. This next example says solve sine of theta plus 2 equals 1 over 0 to 2 pi, and then give all solutions. Okay, the first thing we need to do is we need to solve our trig function for sine. I'll do that by subtracting over 2. So I have sine of theta equals negative 1. Now this is a special case. I said when we discussed an introduction to solving trig equations that most of the time you would have two different locations as far as where the thetas could lie. This, however, is a special situation, and here's what I mean. Sine of theta I know is equal to y over r. Well, in this case, I have that y over r is equal to negative 1. The r value would have to be positive 1 because r is always positive, which forces the y value to be negative 1. There's only one location that that could happen at. If r is equal to 1, that indicates to me that it's going to be a quadrantal angle in this situation. R equal 1 means you're going to have a quadrantal angle. So the angle is going to fall on an axis. Y equals negative 1 will tell me exactly which axis it falls on. If I label this point is 0, negative 1. You notice that y is equal to negative 1 while x is 0. R is equal to 1. That is the only axis that that information is true for. And so in this case, what happens is the angle is always measured from the positive x-axis around to that terminal side. And so in this case, we see that the only answer to our equation is theta equals 3 pi over 2, or 270 degrees. Okay, this problem asked me to solve it from 0 to 2 pi, and so I know that the proper answer would be theta equals 3 pi over 2. And this was over 0 to 2 pi. It also asked me to give all the answers, and so for all solutions, I would take that single angle, theta equals 3 pi over 2, and I would add n times 2 pi. And that would get me all angles that are coterminal to 3 pi over 2. This concludes this example on solving trig equations.